the big piece about why it doesn't work. Because people will say, nope, I put my get name here. Oh, the get name's over here. Oh, the get zip code's over on this one. And all of a sudden, it's not private or public. It's too hard to control. This won't work. So private APIs never work, okay? I have not, well, I shouldn't say that. That's unfair to say. That's bad to say. I have never seen a private API work. How's that? I'm sure somewhere somebody's got it right, but I have not seen it yet. Okay, let's talk about problem number 3, though. Boy, we're not even done with the problems yet. Okay, so let's say that each instance of my microservice, due to my infrastructure, each instance can handle a maximum of 1,000 requests per second. Okay. Well, from our UI, how many customer demographic requests do we get? 2,000 a second. How about from our wish list? 5,000 a second. Well, what Kubernetes or anything worth its weight in salt from an auto-scaling is going to do is to say, well, clearly, if I have 2,000 requests and each instance takes 1,000, I need 2 instances of my customer demographics, and I need 5 instances of my wish list to handle that load. I mean, this is scalability. Okay, and usually I can configure to say auto-scale for me or not. You know, this is why I wanted to add caching to this particular workshop, because auto-scaling can become extremely evil, as we're going to see, because we're going to actually do some mathematics involved with caching, and we're going to see if we auto-scale too much, all of a sudden we get cache hits or data collisions in our caching. And so it matters how many instances we can have. I generally have a small cap on my auto-scale. So the point is this, though. Do you remember? Every request to wish list needs the name. Is that really 2,000 a second right here? No. You know what it is? It is exactly 7,000 a second. Boom! No throughput, timeouts. This will never work. And so now we have 3 problems associated with REST for inter-service calls. I'm not saying not to use REST. I'm just saying understand the 3 problems. We have latency because we're going through all layers of our API. Number 2, we have, actually we have more problems. That second one was the biggest one. Number 2, so this can sometimes be solved by auto-scaling, but if we're using caching, no. So the first that we saw was the latency. The second piece we saw was stamp coupling. And the third problem we saw was overpolluting our APIs with all these inter-service calls to reduce stamp coupling. And the fourth piece was the throughput here. Oy. So what does work? Well, let's look at a couple of other options for inter-service communication that I actually prefer over REST. And the first of those is to leverage messaging. And I'm talking about ActiveMQ, or more properly, RabbitMQ, between service calls. And as a matter of fact, if we analyze this, we have a couple of new opportunities that we don't have in REST. And I should say we don't because we can simulate async in REST, but it's still a synchronous protocol. And so the point is here, now I have opportunities to do a fire and forget, send asynchronous message over to a queue when I don't need a response. So let me show you this. So if I'm making a normal call, the top part here is REST. If I make a RESTful call to be able to get some information or just to post, we're going to post a comment. Watch what happens. I do a wait and make that RESTful call. I post the comment. It's a synchronous call. I have to wait for it to complete. And now it comes back. That's 800 milliseconds because I've got 50 milliseconds latency both ways plus 700 milliseconds on the processing. If I don't need a response, if I just need to tell you something, and I use asynchronous messaging, watch what happens. This is on the bottom. That's it. 50 milliseconds. And now the processing happens, but I've already responded back to the client and said, here you go. Let me give you a real example. Customer comments. I want to place a comment on the website. I call them customer comments, but they're really a comment, but they're from a customer. Okay. It takes 3 seconds to post a comment because I have to parse every single word of that comment, and I have to put it through a bad word checker to make sure that you're not using any bad words. I have to parse it through our own company's bad word checker because our website doesn't allow certain words regardless if the government does. I have to take every sentence and I have to parse it through a grammar checker to make sure that the way we're saying something And grammar is not abusive. I may not have used any bad words, but the way I'm saying something is fairly abusive. I have to pass it through a fourth context checker every sentence to make sure that what I'm saying relates to our products and services and is not a political rant. This is all automated, and that takes 3 seconds. So I'm going to post a comment on our website. Are you ready? Set, go. Here we go. Thank you for your comment. That seemed like a long time, didn't it? That's the last time I'm ever going to post a comment again. I waited 3 seconds of my life to get a thank you. Really, watch this. Thank you. 37 milliseconds to post a comment. Asynchronous messaging, I don't have to wait for a 200. No, I simply fire and forget. It's a send. It sends it to the queue. As a matter of fact, this diagram is wrong right here. Just realize, because I am not sending the message to you. I am sending the message to a queue. That's when I get response back. So the point is, here's another opportunity to look at all the various ways of all the requests. If we want to increase performance, look for all those async opportunities. Now, I know what you say. It's the same argument. It's like, oh, great. Here we have another one of these, use messaging. Oh, it's great. Yeah, what happens if I have a bad word in that comment and it's async? Yeah, this is always the problem with async, isn't it? Yeah, that's all well and good until an error occurs. All right, well, let's do this. So, type, bad word, enter. Thank you for your comment. Well, this is async. How do you get back to me? Well, if it's an anonymous user, that means I have no idea who you are, and I get a bad comment. It's gone. Just delete it. I don't care about you anyway. However, if you're registered on our website, which most people are when you place a comment, what do I have? I have your email. Here's how it goes. Type, bad word, anger, enter. Thank you for your comment. And I go on my merry way, and all of a sudden, bing! Oh, wait, I got an email. I look at the email. Your comment, which we can't repeat here, did not meet our guidelines. Please see our guidelines here with a link showing you how it went wrong. There's usually a way to get back to a client. As a matter of fact, yesterday we looked at reactive patterns of architecture, and I looked at the workflow event pattern. And that pattern is the other way of being able to programmatically handle an error. For example, let's use the workflow event pattern of asynchronous architecture, or event-driven architecture. And so now, watch this. Type, anger, enter. All right. Bing. Well, 37 milliseconds. Thank you for your comment. I love this.